Hey, what's up, everybody? It's me, Mr. Goldman. Welcome back to my channel. Please be sure to like and subscribe. Smash that bell button for notifications. Very excited to bring to you the test solutions for the final chapter test of the year, chapters 8 and 9 combined into one. Without further ado, let's get started. Standard 6, I can create and or analyze box plots. The box plot below represents some data set. What percentage of the data values are greater than 60? Well, 60 is right here. So it's asking about this section, 25%. Each section of the box plot represents 25% of the data. We have the median, half of the data is this way, half of the data is this way. And then Q3 cuts the upper half into halves. So we have quarters, right? Same with Q1. Based on the two data sets represented below, complete the following sentences. Here's data set W, data set X. Notice they're on the same number line, right? So we can compare them directly. The median of data set W, that's right here, is blanked in the median of data set X. Well, it's greater than. Because it's farther up the number line, right? The interquartile range, that means Q3 to Q1, Q1 to Q3. That is the interquartile range. Another way of thinking about that is how wide is the box? And I can very quickly see that interquartile range of data set W is less. It's smaller because it's a narrower box, right? We could do 66 minus 63. The interquartile range is 3 here, and it is 4 here. But we can just look with our eyes. This is a narrower box, so the interquartile range is less. All right, fill in the values below and use them to create a box plot. This is very nice. It is already in order for us from least to greatest. I believe there's 14 values, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So we're gonna go to the 7th one, 1, 2, 3, 4, 5, 6, 7. And that means that's our median. It's directly between 8 and 9. So our median is 8.5, okay? Now let's look at Q1. We just look at these values, and there's 7 of them, so I know there is going to be a middle value, and that is 4. And now for Q3, we look over here. My middle value is this 12. Min is 3, because that's the minimum, and 16 is the max. So now we come down here, and I'm going to not be super precise and just use freehand, but we're going to go a little line at 3, a wider line at, just make it exactly 4. Median at 8.5. Q3 at 12 and a max at 16. And now we're just going to connect the dots. Again, it would have been ideal if you used a straight edge for this, but your box plot should look like that. Standard 7, I can calculate mean, median, and mode. You'll notice I helped myself out a little bit for video. I put them in order from least to greatest, and then I did something here. What do you think I did here? That's right, I added them together. So this is the sum. So this is all these numbers added up. And I have 147. I'm going to divide by 7 because there's 7 values. And that is 21. And that gives me the mean, the average. If I look at the median, again, there's 7 values. It's nice. There's a middle value. So the median is 16. Here, middle value is 30. So that's the median. And 196, I'm going to divide by 7, and I get 28. So the average, or the mean, is 28. I can find missing angle measurements using supplementary, complementary, vertical, and adjacent angles. A and 80 degrees are supplementary. That means they add up to 180 degrees. It's a straight line. That means for A, or number 1, is 100 degrees. Put a little circle there. B and 35 degrees are complementary, so they have to add up to 90 degrees. So 55. If we come down here, J and 75, these are vertical angles. and vertical angles are congruent or the same. So I know that J is 75. K and 115 degrees are supplementary. They add up to 180. So K is 65. Most common mistake on the test. People saw L, they went, oh, it's got to be 65. No, that is not true. How do we figure out what L is? We have to know that inside a triangle, there are 180 degrees. And we've already found J and K. They're right here. If I add these together, I get 140, which means L has to be 40. I'll say that again. L, J, and K have to add up to 180 degrees total. We know J is 75, we know K is 65, so L has to be 40. For M, and L are supplementary. They have to add up to 180 degrees. I just said 180 and I wrote 180. M is actually 140 degrees. Just to make that very clear, 140 degrees. Hard to speak and write. N and P are vertical, so we know they're exactly the same. They're congruent. N is also supplementary to 75 degrees, so N is 105 degrees, which makes P 105 degrees. All right, draw a triangle with sides of 3 centimeters and 4 centimeters and a 90-degree angle between them. Remember, the centimeters ones were these here, so I'll start with 3 centimeters. Viewing window over that. I'm going to put a little dot at 90. It's up here. I'm going to go use that dot as a guide, but I'm only going to go 4 centimeters. And now I have 4 centimeters, 3 centimeters, that's 90 degrees, and I'm going to connect these two to make a triangle. And if I did this correctly, if I did this well, this line should be 5 centimeters for those Pythagorean theorem fans out there. Hey, and I did it. But you don't need to measure that or label that. 3, 4, 90 degrees. Should look like that. Draw a triangle with a 30-degree and a 60-degree angle and one side length of 5 centimeters. For the previous triangle, every single triangle should look exactly like this. Now, it can be flipped over, it can be rotated, but it should look like this. If I cut this triangle out and put it over yours, it would fit perfectly. Not the case with this, because I don't know exactly where the 5 centimeter side is going to go in relation to the angles. But I'll just start with 5 centimeters there. I'll do a 60-degree angle here and a 30-degree angle, which is the same as 150. Well, not the same, but I would use the same markings, right? So it looks like I'm doing 150, but it's really 30. And now here I have to be a little, I'm going to use pencil here. You'll see why. I'm going to connect that. Oh, it's pretty good. And then I'm going to connect here. Okay, so now I have, this is 60 degrees, this is 30 degrees, and this is 5 centimeters. And I'll just either erase that, or for the video, I'm just going to draw it in purple just to show that that is the triangle. Okay, and this angle, if I did it correctly, should be 90 degrees. It should be exactly 90 degrees. It looks pretty good. I'm not going to fully match that, but that should be good because 30, 60, 90. All right, draw a triangle with side lengths of 4 centimeters and 5 centimeters and an obtuse angle. All right, this one, we're going to see the most variety, right? I don't even actually need to measure any angle. 4 centimeters. I'm just going to make sure it opens more than 90 degrees, right? 90 degrees is the right angle. I'm going to open it more than that. And I'm going to measure out to 5 centimeters. And then I'll just show that that's the angle I'm talking about. So there you go. constructing triangles. I can calculate the circumference of a circle in terms of pi rounded to the nearest tenth. Okay, so here's the circle. My diameter is 20, so I'm going to use the pi times diameter. And it says calculate it to the nearest tenth. So I'm going to do 3.14 times 20. 62.8 miles. A circle with a diameter of 5 inches. So we have pi times diameter. Circumference is 3.14 times 5. 15.7 inches. Radius of 4.2. So now I'm going to use a different formula. Circumference equals 2 pi r. So 2 times 3.14 times 4.2. 2 times 3.14 times 4.2. I'm going to round this to the nearest tenth, so that would be 26.4. 26.4 centimeters. Circumference is a measure of distance, so all of my units are just to the first power, right? Just miles, inches, and centimeters. Find the area in terms of pi and round it to the nearest tenth. So here's my circle. It's got a radius of, remember, area is pi r times r, or r squared. My radius is 3 feet. So 3.1, I keep saying 1 and 4 at the same time, times 9 feet squared. So we have 3.14 times 9, 28.26. Nearest tenth is 28.3 feet squared, or 9 pi feet squared. All right, find the area of a circle with a radius of 25 centimeters, round to the nearest tenth. All right, well, here we have, again, pi r times r. 3.14 times 25 times 25 centimeters squared. Again, we all know, of course, 25 times 25 is 625 times 3.14. 1,962.5. 1,962.5 centimeters squared. All right, this is tricky. Find the area of a circle whose circumference is 32.656 meters. So I'm going to find diameter. Diameter equals circumference divided by pi. So let's do 32.656 divided by 3.14. So my diameter is 10.4. 10.4 meters. So again, I want to find area, and that's pi times radius times radius. Well, if diameter is 10.4, radius is half of that. So I have 3.14 times 5.2 times 5.2, and then that's going to be meters squared. 3.14 times 5.2 times 5.2, 84.9. 0.9 meters squared. And again, notice all of my units should be squared here because I'm talking about area. All right, thanks a lot. Good luck on your retakes. Fantastic.